Hello everyone. The title of this video is Use the Vertical Line Test. So in this video, I'm going to be going over several examples in which we're given a graph of a relation. All right, remember, it's just a picture of ordered pairs, x value comma y value, that are plotted on an xy coordinate plane. And we're asked to determine, using what's called the vertical line test, we're asked to determine if this relation that we're given a graph of is a function. Okay. So you have to remember the definition of a function. Right? A function was a relation in which every x value, right, every value of the domain is assigned to exactly one y value, right, or exactly one value of the range. Okay, so if you remember that definition of a function, that will help out quite a bit. Right. So the exercises I'm doing in this video are taken from a free online textbook at openstacks.org. This is their Intermediate Algebra 2nd edition text. And I'm in section 3.6 on the graphs of functions. And I'll be working in this video on the exercises 337 all the way through to 340, right, parts A and B. And when I refer to example numbers, in my video, example 1 will correspond to 337 part A. Example 2 will correspond to 337 part B, and each part of every problem will be a new example. All right. So, and again, if you'd like to see a specific example, just count down how many parts you want to go to, and then look for that example in the description of the video. All right, I will have timestamps for each example in the description. Okay. All right. So first off, what is this vertical line test? Well, I'll just have it pop up on the screen here for you in a second. Okay, and here it is from that same section. The vertical line test. So a set of points in a rectangular coordinate system, that means the xy coordinate plane that you're probably used to graphing relations on, is the graph of a function if every vertical line intersects the graph in at most one point. All right, let me say that again. A set of points in a rectangular coordinate system is the graph of a function if every vertical line you could possibly draw, straight up and down, right, vertical line, intersects the graph, hits the graph in at most one point. So every vertical line you draw either hits the graph at one point or it doesn't hit the graph at all. But if any vertical line intersects the graph in more than one point, then the graph does not represent a function, right? That would not satisfy the definition of a function. Okay, so let's actually now get into our examples, our exercises. Okay, so the first of these exercises, again, number 337 from this section, part A. And I'll pull up a page here where I have the website up, and you can also see hopefully a piece of paper in the lower right corner of your screen, of the video screen. Alright, so example 1, right, 337 part A. And we're asked, in the following exercises, determine whether each graph is the graph of a function. And I'll do a quick sketch on my piece of paper. I wanted at least a good looking version of it. That's why I had the website up. But I'll do a quick sketch as well. And it looks like this is the graph of a circle centered at the origin. So one of those points looks like it's at 3, 0. Right, there's the ordered pair 3, 0, and then 0, 3, -3, 0, and 0, -3. Right, again, just looking at the picture there, and then it's a circle. Right, a bunch of, this is infinitely many ordered pairs, this relation. Now the vertical line test, as I mentioned, if the graph we're looking at is the graph of a function, then every vertical line that's drawn will either not hit the graph at all or hit it at one point, exactly one point. And if you can find any vertical line that hits the graph more than once, then it's not a function. Right? So like this one here, I can tell right away this is the graph of a relation that's not a function. Look at the y-axis. Right, here's a vertical line. Let's do the y-axis here. Right, straight up and down. Right, here's a vertical line, and it's a vertical line that hits the graph, hits or intersects the graph more than once, and that's not good. Right? You see it intersects the graph. This vertical line, the y-axis here, hits the graph here and here. Now those ordered pairs, right? This is the ordered pair 0 for x, -3 for y. This point up here is the ordered pair 0 for x, +3 for y. All right, so hopefully you can see that if a vertical line hits a graph more than once, that means that there is an x value that is assigned to more than one y value, and that does not satisfy the definition of a function. Right? We have 0, 3, 0, -3 are in this relation. That means that, if you were looking at a mapping, 0 in the domain would map to or be assigned to 2 different values in the range. And you may recall from a previous video or or whatever other reading you've done on functions, that can't happen in a function. Right? One more time, in a function, every x value corresponds to exactly one y value. Every value in the domain is assigned to exactly one value in the range. So definitely not a function here. This graph we are given, all these ordered pairs, all these infinitely many points on the circle, that is not the graph of a function. Right? Now you don't have to even identify specific ordered pairs, right? You could have just said, hey, here's a vertical line up and down that hits the graph twice. That hits the graph more than once. There's, as long as you can find one of these, right? If you can find just one line, one vertical line that hits the graph more than once, it's not the graph of a function. All right. All right, example 2, which is number 337, part B. So again, I'll draw a little rough sketch on my paper so we can start drawing our vertical lines and stuff. So x-axis, y-axis. And this is what they call looks like a parabola. Right? And it looks like the lowest point there is at 0, 2. the point 0, 2 based on the notches. And it's just this curvy thing, you know, like a U shape opening up, right? Going that way forever, that way forever. Right, and we're asked again, you know, is this set of all these ordered pairs, right, this relation, a function? So can you see that when you draw a vertical line, any vertical line, it'll hit this graph in at most one point. Right? That vertical line hits the graph once. The y-axis hits the graph once. This vertical line hits the graph once. This vertical line hits the graph once. Every vertical line, right? And it's got to be every possible vertical line in order for the graph to be a function. Every vertical line will hit the graph at most one time. Or will intersect the graph at most once. That means that this graph, this set of ordered pairs here, this is the graph of a function. Right? So this is a function. Satisfies that definition. Right? Every single value of x, every value in the domain, corresponds to exactly one value of y. Right? Like this point here is the point 0, 2. So the x value of 0 is assigned to the y value of 2. And that's it. And every x value, right? Every x value is assigned to exactly one y value. Thus a function. Right. Okay, next example. And again, I'm just going to keep drawing these rough sketches. This is number 338, part A. So again, I'll draw a rough drawing over here, x-axis, y-axis. And it looks like it goes through the origin and, you know, kind of is this like S-curve thing. Going that way forever, that way forever. And yet again, take any vertical line, even the y-axis. You know, the drawing here, I draw any vertical line. This vertical line hits the graph once. This one hits the graph once. Once. Again, I can't see it. Right? I can't see any vertical line that'll hit the graph more than once. So once again, we have the scenario where every vertical line, you know, hits the graph at most one time, right? 0 time or 1 time, but not more than once. And I'm not going to write this every single time here, all right? But yeah, so if that's the case, if every vertical line hits the graph at most once, then the graph is the graph of a function. That relation is a function. Okay. And to show that if a graph of a relation is not a function, you only need to find one vertical line. Sorry, this was example 3. You only need to find one vertical line that hits it more than once. That's it. Right? You don't have to just one. Okay, example 4, number 338, part B. So this is pretty much like example 1. And I'll make a very rough sketch of this. another circle, centered at the origin. I'm not even going to put numbers up. All right. All these points are in this relation, all these ordered pairs. Here you go. You could do the y-axis or this line here. Hits there's a vertical line straight up and down. Hit the graph once, hits the graph twice. So here's A, and that's all you need to find is a single one. There's a vertical line that hits the graph, or intersects the graph more than once. And if that is the case, right, if you can find that, right, if you can find a vertical line that hits the graph more than once, then this relation, right, the picture of all these points is a graph of a relation that is not a function. Because there are x values, like this one here, right, whatever this x value is on the x-axis, there are x values that are assigned to more than one y value, and that doesn't satisfy the definition of a function. Right, hopefully this is pretty simple. Right. I'm hoping. Alright, example 5, which is number 339, part A. Now you have another parabola, like in example 2, but it's a parabola opening in a different direction. And so here's x-axis, y-axis. Looks like starting over here and then opening up this way, and like this kind of a parabola shape. Again, very, very rough sketch I've just made, but I'm not even going to label any numbers here. We can very easily see that this is not the graph of a function. Because I can find a vertical line. Here you go. Here's one. I can find a vertical line that has 2 points of this graph on it. Right? That has more than 1 point of the graph on it. Hits the graph more than once. So this graph I was given, this relation, not a function by this vertical line test. Very, very simple. Right, so I'm going to kind of go a little faster now for the rest of these examples. Should be pretty easy. 339 part B. This example 6. Again, it's like one of those S-shaped graphs, like in example 3. But it's going, instead of left to right, it's going up and down like this, going through the origin. So yeah, draw any vertical line you want. This vertical line, the y-axis, this vertical line, this vertical line. Draw any vertical line you want, and it hits the graph one time. All right. That means that every x value goes to exactly one y value. This is a function. This is the graph of a function. Very, very, and that's because every vertical line will hit this graph at most once, not more than once. Right? Okay. Example 7. This is exercise 340, part A. So again, a weird looking graph. Now this is the graph of something called a hyperbola, right, with the two branches here, 2 curves. Example 7, in a rough sketch. Now you can probably very easily tell that this is not the graph of a function. Right? You got this curve here, and this curve here, right? Just making a very, very rough sketch of this. All these ordered pairs, right, belong to this relation, but this relation clearly, again, is not a function. Because all you need to do, one more time, all you need to do to show that a graph of a relation is not a function is find one vertical line. Here you go. Find one vertical line that hits the graph more than once, which this one does. That means that this x value here, this value of x on the x-axis, this x value corresponds or is assigned to more than one y value, which means this relation is not a function. doesn't satisfy the definition of a function. All right, so not a function. And then finally, all right, the last example. Again, these are all pretty simple, I'm hoping you're seeing. Example 8, exercise 340, part B. And I'll make a very rough sketch here on my paper. This is just some V-shaped graph looking like this. You know, all these ordered pairs, all these infinitely many points, belong to some relation. And the question again is, is this relation that's being graphed here, this set of ordered pairs, is this a function? And from the vertical line test, we can very clearly see that it is not, right? All you have to do to show that a relation is not a function is just find one vertical line that hits the graph more than once. There you go, right? There's a vertical line that I just drew that hits this graph more than once. That means that this x value, right, whatever this x value is assigned to more than one y value, right? This value of the domain is assigned to more than one value of the range. That does not satisfy the definition of a function, right? And one more time, a function, every value of the domain is assigned to exactly one value of the range. Right? So again, we have a graph here that's not the graph of a function. Very, very simple stuff, I think. All right, this vertical line test. All right, and hopefully watching me do these examples here, help you out when you're working on similar problems. And thank you very much for watching.